Good morning, year four. I'm going to try this and see how this works. It may work well, it may work dreadfully. You might love it, you might hate it, but let's just see um, if I can do this and see how this goes. Anyway, our lesson objective today is thinking about comparing decimals. Okay, so we're going to be thinking very carefully about our place value. We talk about it all the time in our place value grid and what's the place value of that. So we're thinking very carefully. We looked at it before Easter. Right, the first question here then is find 6 complements of 1 on the grid below. Now, first of all, I'm thinking, well, hang about. What does this word mean? Complement. I want you to think about it for a minute and see if you could imagine what do you think they're meaning by a complement. Have a think. You can pause the video if you'd like. But a complement basically is 2 decimals that equal 1 whole. Okay, I could, for example, have, if I can write here, it's very scrolly, so I do apologize. I could have 0.5, ooh, and I could have 0.5, okay? So I could have 5 tenths plus 5 tenths is equal to 10 tenths, or 1 whole, okay? So looking at these numbers, I want you to think and partner up which decimals you think would add together to make 1 whole. You can pause the video, have a look, and see if you can identify the pairs of decimals that equal a whole. Okay, so hopefully you have discovered that 0.4 and 0.6 equal to 1 whole, 0.8 and 0.2, 8 tenths and 2 tenths, 10 tenths, yep, that makes 1 whole, 0.1 and 0.9, 9 tenths and 1 tenth, that equals 1 whole as well, fab, and 0.55 and 0.45 added together would make 10 tenths or 1 whole, and 0.64 and 0.36 also equal 1 whole or 10 tenths. But I hear you thinking, oh my goodness, how do we actually know that that is correct? Well, let's actually add them together, because you think, you know what, Mrs. Harrison, you're always asking us to prove our answer, so let me prove to you that 0.64 and 0.36, if we add them together, make 1 whole. So over here with my scrolly writing, so I'm going to put 0.64 and I'm going to make it look like column addition. Do you remember that? Oh yeah. Plus 0.36, and I'm going to just add these together. I'm laughing because my daughter is crawling around on the floor behind me. So I'm going to just add these together. So we've got 4 hundredths and 6 hundredths make 10 hundredths, okay? So I can put down my 0 here, and I've got my 1 that I take over here to the tenths column. And then, oh, hang on, let me label these. So these are my 1s. Oh, there's my decimal. These are my tenths. And these are my hundredths. Okay. Now I have 6 tenths and 3 tenths, which makes 9 tenths. But then, hang around, I've got another tenth down here. So 6 tenths plus 3 tenths, 9 tenths, put another tenth is 10 tenths. Or 10 tenths or 1 whole. There's my 10 tenths. Put my decimal place in. Boom. 1 whole. Okay. Slide. So write down and compare these decimals using the greater than, less than, or equals. Okay, now look at these place value counters first of all, and we need to identify what do they actually represent, what do they show. Well, let's start here and think about the purple ones. Well, straight away I'm thinking they are 1. So how many holes have I got here? Well, I've got 2 holes there. Fab. And then I'm going to move over to the green ones. So they're showing me the tenths, because I know tenths are straight after the first place right of the decimal. So they'll have to go in here. And I've got 2 of those. So that's 2.2. And now my next place after the decimal is my hundredths. And how many have I got? Oh, I've got 3. So the number here is 2.23. I want you to have a look at the other side and see if you can write down what number this is showing. And if you can tell me which is the greater number. And hopefully you have identified that the number showing over here is 1.23. Okay, and you've recognized that 2.23 is greater, and straight away we know that because there's 2 holes there. 2 holes are always going to be greater than 1 hole, so you immediately can hopefully recognize that and justify why. Okay, here we go. Here we've got some place value grids here again. So let's having a look. I always like to label these really, because this is my ones here. Okay, my 1 hole, that's my decimal. The writing is just awful. These are my tenths, and these here are my hundredths. Let's do the other side too, because it would be wrong to just leave this guy out. So these are my ones. Okay, that's my decimal point. Here are my tenths, and here are my hundredths. Write down for me now, pause the video, and can you write down what these represent first of all? What numbers are showing on this place value grid? Okay, pause it, write it down. Lovely. Hopefully you've recognized here that I've got 2 holes here, and I've got my decimal point. I've got 3 tenths, and I've here got 4 hundredths. So the number shown there is 2.34. On the other side, we've got 3 holes. I've got no tenths. Oh, but how many hundredths have I got? 1, 2, 3, 4, 5. I've got 3.05. And where would our symbol go? Well, straight off, hopefully you've recognized that 3 holes is always going to be greater than 2. So 2.34 is less than 3.05. Right, let's go. Next one. Have a careful look at these, because we can look straight away and see that the whole numbers are the same. Okay, in all of these, the whole numbers at the beginning are the same. So now we need to go to the next space or the next place after the decimal and look at the value to see, well, I've got 6/10 here and I've only got 3 here. So straight off, I know that 5.63 has to be bigger because it has 6/10, and this number over here has only got 3. So I know straight off, well, 5.63 is greater than 5.36. I want you to look at the next 2 and write down what you think the symbol going between those numbers are. Okie doke. And hopefully you've recognized here that we've got 4/10 and 4/10. Well, I've got 0/10 here. So this is the larger of the two, even though they have the same digits. Here again, I hope you've recognized, looking at the tenths, that I've got 8/10 and I've only got 7 here. So 7.8 is greater. Okay. Now, using digits 1 to 9, make these statements correct. Make these statements correct. So the first statement is saying 0.54 is greater than what? Okay, now thinking carefully, what digit needs to go in here? Okay, because these numbers are starting the same, 0.5. So to make this greater, 0.54, whatever goes in here has to be less than 4. There are multiple answers here. You can write down as many of them as you want, but to make 0.54 greater, whatever digit goes in here has to be less. So it could be, for example, 0.51. Okay, what other solutions can you come up with for this one? Okay, what other solutions? I've given you one, can you come up with another? Look at the next one down here. I want you to pause here for a minute and I want you to think very carefully. This is an equals one. Okay, just looking at that. So, and what solutions can you come up with? I want you to pause and write down as many as you can come up with. Okay, so here we've got 0.54, it's greater than 0.53. Again, you could have other solutions here. 0.17 is less than 0.18. I could have had 0.16. 0.15. You should hopefully have come up with lots of different solutions here. Just don't give us one, you know. And again here, well, there was only one answer here, isn't it, to make these equal. Right. Next question is to travel vertically or horizontally, through the maze. So we have to get from one side to the other. We're starting here, okay? Got to get down here, lovely. By moving from smaller to larger decimals. Smaller to larger, that's the key here. So I want you to pause the video for a minute and I want you to have a little think. If you're going from smaller to larger, how you're going to work your way through the maze. And hopefully you will have found the solution. Okay, so we've started here. Okay, at the smallest one, we've gone to the next 6.45, 6.81, 6.93, 6.72, and all the way to the finish. Okay, so let's have a look here. We've got use the greater than, less than, or equals to compare the partitioned decimals. Okay, so the partitioned, what does that mean if we've partitioned a number? So do you remember, for example, if we had a number like 15, okay, and we partitioned it, we could partition it into 10 plus 5, okay. Now these decimals have been partitioned, so in order to work out which symbol goes between them, well, really we need to recombine them or put them back together. So we've got 0.6 plus 0.02. So if we put those together, we're going to end up with the number 0.62. And likewise over here, if we combine 0.3 and 0.3, well, I know 3 and 3 is 6, so 0.3 and 0.3 is going to equal to 0.6. So what's the largest number here? What symbol do you think would go in there? Well, I know that 0.62 is going to be larger than 0.6 because over here I've got 0.6, but I've also got 200ths over here, and here I don't have anything really except 0. Put my placeholder in there, 0, so that's just 0.6. So 0.62 is going to be larger or greater than 0.6. I want you to have a look at this one down here. I want you to recombine what do you think this would be. So we would have 0.04 and 0.05, add them together, what would it be? You can pause the video. And over here I've got 0.4 and 0.05. So while the same digits are being used, where those digits are placed is different, therefore affecting the value. Okay, so here then, if I add 0.04 and 0.05, well, I know that 4 plus 5 is 9, so 0.04 plus 0.05 is going to be 0. Hang on, it's very hard to do the decimal, 0.9. Okay, and over here it's going to be 0.45. Okay, so which number do you think is larger? Remember, as we move to the right of the decimal place, the numbers or the value of those numbers is becoming less. Okay, so tenths are going to be larger than hundreds, and the next one down would be, of course, thousands, which would be smaller again than my hundredths. Okay, so as I'm moving to the right, numbers are getting smaller. The numbers or the value of those digits are getting smaller. So here, of course, I've got 4/10 here, and I've got 0 here. Okie doke. And this is what the solution should look like. All right. Okay, moving on. Okay. Agatha says, I have made the longest train track because it is 1.2 meters long. And Oscar says, I have made the largest train track because it is 0.21 meters long. Who is correct and why? Well, have a think about that for a moment. I want you to pause and give me some justification. She has a train track 1.2 meters long, and old Oscar down here has one with 0.21 meters long. And who is correct, and can you explain why? Well, okay, so Agatha is definitely correct, okay, because her train track is 1.2 meters long. She has 1 whole meter and 0.2. So in fact, altogether, if you were to think about that, her train track, if I get the right color here, is actually 120 centimeters long. It's 120 centimeters long, her train track. Now, thinking about Oscar's train track, well, his train track is only 0.21 of a meter, so only part of a meter. He hasn't even got 1 whole meter on his train track. And his train track is actually, it's only 21 centimeters. So Agatha is correct. Her train track is much longer because she's already got 1 whole meter, which is 100 centimeters. So Agatha's train track is larger. Okay, that is the end of the slideshow. I hope it's been useful. Please pause it whenever you think you need to as you're going through it, and let me know and give me some feedback about how you found it, and see you soon. Have fun doing your maths. I hope you're successful. Bye.